This demonstration shows how to share data with Shark and other applications using the AutoCAD DWG format. Shark supports reading and writing DWG files based on version 2.5 through AutoCAD 2009. Shark provides model and paper space support for curves, surfaces, and solids, as well as annotation entity types such as text and dimensions. This demonstration shows the following features of Shark: the ability to read, modify, and export DWG files. First, let's go in and read in some sample files. Go over here and we'll drag and drop a DXF file in of a sample floor plan. Next, let's read in a fire hose nozzle. And then let's read in a detailed drawing of a part. And in this particular example, let's go to our Concept Explorer where we have our Layer Manager. For those with AutoCAD, you'll find some familiar features, including the ability to set the work layer, set the visibility, rename a layer, add a layer, lock a layer, provide a color override. In fact, in this case, the DWG file has some color overrides in it that you see are preserved when we read the file in. To change a color override, click on the color swatch. It will toggle through, or you can remove any override associated with it. The next file demonstrates some of Shark's ability to support paper space entities. Let's talk a bit about model and paper space. These are two important concepts in AutoCAD that impact the contents of a DWG file. The two drawing spaces that AutoCAD provides are model space and paper space. Objects that represent the subject of a drawing are normally drawn in model space. Paper space represents the paper that you plot or print on. Normally, the only geometry that you see is the title block, a border, and some annotations in paper space. Additionally, you'll see the viewports, which define regions and scales that go back into the geometry. When you read in a file with paper space, you'll see that the Layer Manager sorts the model geometry from the paper space or the sheets. To display a sheet or paper space, right-click, select Isolate Branch, and you'll see that sheet displayed. Let's display some more. Now, one of the reasons why paper space is so popular is it does provide an easy way to set up a print or a plot. Let's demonstrate how we would print or plot this paper space entity. We'll go over to the File, Page Layout. Let's go ahead and set our page setup to Landscape. Now let's tell it to fit to the area, and let's show our page breaks relative to our drawing. Next, let's go ahead and hit the Print tool, and we're going to go ahead and send this off to a PDF file. Let's go ahead and click it and preview what we just printed out. There we go. In our next example, let's go ahead and read in a DXF file and do some modifications on it. Now, one of the key advantages of Shark DWG files is its ability to natively support precision surfaces and solids that are embedded in SAT data. This, for example, is a precision solid that was stored in the DXF file that we just read in. SAT is a native format for the ACES modeling kernel used by Shark. The ACES modeling kernel was also used by AutoCAD, which provides us a path to accurately share data between the two applications. Let's go ahead and take this DWG file and let's do some modifications on it. let's zoom in on this fillet, and we're going to pull out our local face operation tools. These tools allow us to do foreign part editing, including removing faces, matching faces, offsetting faces, and such. In this example, let's go ahead and let's see if we can, let's see what the existing arc radius is 0.118. So let's go ahead and replace that with a larger one. So let's do a remove face. And then let's go back to our blend tool and let's change the radius to 0.2 inches. And let's select our edge. And there we have a new blend. Next, let's slide over to this hole and let's do a match face. Match face lets us take this face and orientate it to the same height as this referenced face. Next, we'll do an offset. We'll select this face and we'll off it 1/4 of an inch. And finally, let's select the bottom face and let's move the whole face down. Let's move it down 1/2 inch. We'll go back over to our DZ field and exactly specify 1/2 inch. Great. Now let's go ahead and let's take our part and let's make a drawing out of it. To do this, we'll go to our model sheet tools, select our part, select the layout, which contains a title block and sheet views, and we'll pick our method and our scale and tell it to generate a drawing that consists of a side, top, isometric view nested inside of a title block. In this case, each of these highlighted views are now drawing views with scales associated with it. Let's pull out some more 2D tools associated with this. For example, let's go ahead and generate a section view, and then let's generate a detail view. We'll pull that off over here, and then let's export this out as a DWG file. Let's go to Export, DWG. We'll send it out as an R2008 file, and we'll click OK. We'll call this our widget example. And then what we'll do is we'll take our file, read in AutoCAD files. In this case, we're going to bring it into eDrawings. And let's bring it in and visualize and pan around the file that came in. So we're just demonstrating the capability to write DWG files. Alright, let's quit all this, and that's the end of our demonstration showing our ability to share and work with DWG files.